Alright, there are some numbers that are just too big to mean anything. A billion light years, that doesn't mean much to most people. If you walked up to someone on the street and asked them how large the universe is, they would probably just tell you it's big or infinite. They wouldn't be able to tell you how big the universe is, just that it's big. And there's always those numbers we hear, like how the universe is 93 billion light years long or 13 billion light years long. But truthfully, these numbers have no real meaning for most people. It's just a big number that sounds kind of impressive, and in this video, I'm going to make sense of these numbers. Not just with stars and galaxies, but with real, true perspective of the scale of the universe. And by the end of this video, you should not just know how large the universe is, but feel how large the universe is. Alright, but first we have to start with light. Light is fast. Light is really fast. It's the fastest thing in the entire universe. Light moves at around 186,000 miles per second, which is pretty fast. And in just 1 second, light can travel around the entire Earth 7 times. And the important part is that light is very fast, but it isn't instant. Because light has a definite speed, we can use it to measure distance in space. The most common unit of measurement in astronomy is an astronomical unit, which is the distance between the sun and the Earth. That distance is about 93 million miles, and it takes light from the sun 8 minutes and 20 seconds to reach Earth. So when you look at light from the sun, you're actually technically seeing 8 minutes into the past, because it took the light 8 full minutes to reach your eyeball from the sun. But let's expand on this a little. It takes light from the sun to reach Jupiter, it takes about 4 hours. And for light from the sun to reach Pluto, it takes about 5.5 hours. And if we zoom even farther out, past Pluto and past the Kuiper Belt, we reach the Oort cloud. The Oort cloud is the shell of icy debris that surrounds our solar system, and it's on the outer extent of the sun's gravitational influence. And light from the sun takes anywhere from 1.5 years to 2 years for light to reach the Oort cloud. And just to be clear, our entire solar system, from the sun all the way to the Oort cloud, is 2 full light years long. And that's important because the nearest star to our solar system is Proxima Centauri, which is 4.2 light years away, meaning that it's more than 2 full solar systems away from us. And at this scale, we're no longer talking about planets and orbits. Most of this distance is just empty space. And so now we are beyond the solar system, and this is where distance really gets wild. In our galaxy, the average distance between stars is usually 4 to 5 light years long. Proxima Centauri, the closest star to us, is a pretty standard example. It might sound pretty far, but in galactic terms, it's pretty close. The Milky Way galaxy, the galaxy that we live in, is about 100,000 light years across. It holds anywhere from 100 to 400 billion stars. Every single little point in the night sky is just one tiny piece of our galaxy. And the Milky Way galaxy is not alone. There are countless other galaxies around us. The closest major galaxy to us is the Andromeda galaxy, which is 2.5 million light years away. To put this in perspective, it's like placing 25 of our Milky Way galaxies end to end, and together the Milky Way and the Andromeda are part of what's called the Local Group, which is a group of about 50 galaxies spanning across 10 million light years. But even that is a speck in something bigger. And if you zoom out even further, you reach the Virgo supercluster, a massive structure consisting of thousands of galaxies, including our Local Group. At this point, we are on scales so vast that light, the fastest thing in the entire universe, takes hundreds of millions of years to travel across this distance. But we are still not done. If we zoom out one more time, we finally reach the observable universe, this cosmic sphere that stretches 46.5 billion light years in every direction from Earth. That means that the total diameter of the universe is 93 billion light years. But you may be wondering, if the universe is 13.8 billion years old, how can it stretch 93 billion light years across? And It's because space itself is expanding. Now, ever since the start of time, galaxies have been moving away from us. Not because they're actually traveling away from us, but because the space underneath them has been stretching. So, when a galaxy emitted light billions of years ago, it would have been much closer. But as that light was traveling towards us, space was being stretched and moving the galaxy farther away. This makes it so the light we see left those galaxies billions of years ago. But now those galaxies are much further away than the 13.8 billion light years because space has been expanding and moving them away this entire time. This concept is a bit tricky, but the key idea is that we can only see as far as time has allowed light to travel to us. But thanks to expansion, the actual distance of those galaxies is far beyond the age of the light that we're seeing now. And the mysterious part is that we call this the observable universe because this is all that we can see and observe. Anything beyond this, we have no idea of knowing what it is. There simply hasn't been enough time in the universe for the light past 13.8 billion light years to reach us. And no matter how long we wait, the light beyond this horizon will never ever reach us. And it's likely we'll never know if or what is beyond the observable universe. Based on math, simulations, and the shape of the universe, some scientists believe the universe could be up to trillions of light years across, while others think it could be infinite. Everything around us could just be everything around us. There might not be anything more past it. But we could also be a tiny pinch in something much greater. So after everything we've just covered, from planets to stars to galaxies to the edge of what we can even see, you might be wondering, what's even the point of these numbers? And the truth is that the true scale of the universe isn't just light years or star counts or mind-blowing distances, but it's what it makes you feel. It's about realizing that we're just standing on a tiny rock orbiting like an average star, and we're one galaxy out of trillions of galaxies. It's about understanding just how far we've come from just sitting down, looking at the stars and asking questions. It's about sitting with that feeling of being small, yes, but also that feeling of being connected to something so unimaginably vast. Because when we talk about the true scale of the universe, we're not just talking about the numbers, but we're talking about our place in the universe. And the fact that we can even begin to comprehend these numbers and distances is pretty incredible. Anyways, thanks for watching. If this video helped you feel any more awe for the universe, definitely consider liking the video and subscribing, and there will be more stuff like this. So until next time, peace.